Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother Joel. We are here to hopefully show you how to approach SAT math questions. This is question 31 from a calculator section, and we may actually have to use the calculator today. Okay, read the question, try it, and come back. A partially filled pool. So let me draw a pool. Oops, too thick for Seth. A partially filled pool contains 600 gallons of water. A hose is turned on and water flows into the pool at 8 gallons a minute. After how many gallons of water will be in the pool after 70 minutes? Wow, seems to be a pretty straightforward problem, isn't it? 600 plus 8 times 70? I think so, right? Except,
well, we'll draw the pool after the 70 minutes.
Right.
Maybe use a different color.
Yeah, different color, right. Yeah, different color, blue. 70 minutes at 8 gallons a minute adds 70 times 8, which is 560. And that's added in after 70 minutes. So the total is 1160. Yep. Right? I mean, this is also a y equals mx plus b problem. You know, the b is the initial amount of 600. The slope, the rate, or the slope is 8. 8, and the units help, right? 8 gallons a minute. 8 gallons per minute times 70 minutes. The units cancel, so you get gallons plus the initial amount.
Yeah. Well, I think the pitfall of this problem is to forget or overlook that the question asks for how many gallons of water will be in the pool after 70 minutes.
Right.
Which that includes the 600 gallons that are in the pool at the start. So I think the pitfall that they built into the question is that they expect careless people to simply forget to not observe that that's the quantity they asked for, and merely to figure out how many gallons flowed into the pool during the 70 minutes. So the pitfall is forgetting to add
you're forgetting to add the initial amount.
8 times how many? 70.
70, right.
Don't forget. Don't.
Yeah. You can just say it. You don't have to write it. Yeah.
Don't forget the 600 for this problem.
Right. So in other words, some people would just say 560. Yeah.
Yes.
So the bottom
some
line
people would just say that. Some people would just realize that the problem entails multiplying 8 by 70, and they'll multiply 8 by 70.
Right.
Get 560.
I know. We said it 10 times.
Yeah. I don't know, about 3 times. And they'll put in 560 as the answer.
You said it 10 times. So the bottom line...
No, I didn't. No, 10 is an overestimate.
I can't go back to the video. We probably said it 8 times. But what is the real takeaway? The real takeaway is you got to really read the question. Now, I guarantee you, everybody studying for the SAT has made mistakes like the Seth mentioned. Learn from your mistakes and be careful. Notice that you have to be really careful about this. And I'm sure everybody, including myself, Seth, we all have made this mistake. Just be ready for it, maybe not to make it on the SAT. Okay.
All right.
So today's Thursday. Wow. So today's Throwback Thursday. We're going to do a question from a test from about 20 years ago. Um, okay. Question has been previously located, although neither of us have done it yet. Notice we're
Hmm.
going back in time. It's like a time lapse here. Uh, yeah, here we go. 126. That's today. Here we go. Now this thing, there are things out there called area puzzles, and maybe after we're done, we'll do a share screen and we'll check out what an area puzzle is. But this looks like an area puzzle. I mean, it could be on the modern test, the post 2016 test, but we haven't really seen questions like this much on the 2016 test. Anyway,
Hmm.
give it a shot, everyone. You can pause and we'll get back to us and we'll see what to do. Wow. Okay. Should we start labeling this thing? Area here is 35. Area here is 45. Area here is 36.
Hmm.
What is the area of that? The
Put a
length.
question mark on it.
What is this area? Well, maybe this, I don't know, this isn't so obvious, but it is if you think about it, it probably will be. The area is,
Okay, thinking about it a little,
yep,
what I come up with is what is common to those rectangles in the figure. And what's common to them, a feature that is important for thinking about area, what's common to them are the common lengths of some of the sides.
that's right.
So what I'm going to do is make a variable named x an unknown, which stands for the length of this side, length from which I indicated in the diagram.
Right.
So is that reflected in what
Yes.
people can see?
Yes, everyone sees that. Yes.
And then there's another common length, the height of rectangles A and B, and let's call that y. And I draw the lines to be there. And then there's a third variable, the height of rectangle C. That's Z. Okay. And then what we get from this is, in terms of these variables, what we're trying to find out is the, well, you wrote question mark for the area of D, but the question is really, what is the area of the entire figure?
That's right.
It's not the, so what you could find the area of the entire figure if you calculate the area of D and then add it to these three numbers. But the question is, what is the area of the entire figure?
That's right. That's right.
Well, in terms of these variables, let's see. Since these are rectangles, Z is also the length of that, and Y is the length of this. Okay. So in terms of X, Y, and Z, the answer, the area of the entire figure, okay, let's do it. Let's bring the X down to here too. And, oh gosh.
Got another variable there that you didn't
Another
define.
variable. Oh, well.
Yeah.
So we have W.
Right.
Okay. That's W. Okay, so what we want to figure out is Y plus Z times X plus W. What's that?
Right.
But now, what do we know? What we know is that from I'll do it. I'll use blue for this. What we know from the information is that X times Y equals 35. Y times W, right, equals 45. And Z times W equals 36.
Okay.
Now, well, let's see. I see these X and M products of these things, and so I'm inclined to multiply out to see if I could use the information here to solve the problem
Do you
here.
know exactly
So
what you're? Seth, do you know exactly what you're doing? Or are you just doing it on the fly?
I'm doing it on the fly. I don't know if this will give the answer. So multiply this out.
Okay.
I get y x. Yeah, I'm using FOIL, right? Y times x plus y times w plus z times x plus z times w. That's what I want to know.
Right.
Now, I could just rewrite y times x is x times y, and I know that this is 35.
Right.
Now, y times w is 45. Z times x is the area of D, which we don't know. And z times w, let's see, z times w is the area of rectangle C, which is 36. Okay, so this is not helping. We don't know.
Right, now this is actually how you do the problem. We are doing the problem live. Obviously, Seth really doesn't know how to do this. Yet. But he still. This is how you actually do the problem real time. Right? Nobody actually is embarrassed enough to show this. I have a feeling that there's something about getting some information about multiplying these together and then using that to help you get this length. There's something, I get this feeling that if you add 45 and 36, that's equal to this times this.
Yeah.
A times B, right? But then this area, yeah, that's how to do it, right? I'm doing it a little bit of pre-thinking. I'm not putting numbers in, right? If you get A times B, we know A times B, right? Right? Because A times B is 45 plus 36. Right? Now, we know that...
Wait, hold on. What are you saying? A plus B.
A times B is 45 plus 36. This is A, this is A, this is B. The height is A, the width is B. A times B is... We know A times B. We don't know what it... Wait. What
are you talking about A times B? I don't understand the multiplying.
This is A. This distance is A. This distance
so you're saying A, your A, little a, is...
Yeah,
E plus Y.
Yeah, my little a. Yeah, the A times B. We know A times B. Now we also know C times B, don't we? We also know C times B is. We also know C times B. Wow. So if we know A times B is a known quantity, and C times B is a known quantity. We would.
What is C?
C is this distance.
So your C is my X.
Yes. C times B we know, and A C.
Wait.
No.
How could you know C times B?
No, we know. Well, we we know A times B. There's something about relating these areas. We know this height, right? There's something about A that we know, because A times B has to be a number. And then C times that same height. Oh, God.
This is tricky. Ah,
So, but okay, fine. We know A times B, right? And then we know that here, C plus B. Oh my God, times this height. We know that.
which I called Y.
Yeah, we know that. We know C times B plus Y. We also know.
Times Y.
We also know, but we don't know A, B, C, or Y. Now the whole area, we really, God, we really want to know. You know, if we knew this whole distance, if we knew the black whole distance, and we knew the brown whole distance, we'd be okay, right? Is that right? We really only.
I don't see the brown.
Okay.
Whole distance.
I know I have a gut feeling about this. This looks like a shaded region problem. I feel like a shaded region problem. And we only need two things. We only need the black distance and the brown distance. We only need the total width, the total height.
I don't see brown.
Okay, you'll see it in a second. It's the height. We only need the total width of this thing and the total height of this triangle. Because if we know the total heights, then we subtract. We do black times brown minus 35, 45, and 36. It's coming, Seth. It's coming. So why don't we? I know it's slow. Why don't we try to? Do you see it yet? Oh God, this thing is like, maybe we do have to get another thing besides Zyteboard. If we knew the black and the brown, we're done. Because then we do black times brown minus 35, minus 40. Yeah, if we knew black and brown, we're done. So really we need black and brown.
Yeah.
Maybe we should go for the whole distance. How do we get the whole distance? Wait. Oh, no, we don't. Let's go back to the givens. Are we missing something? The areas of those rectangles are that. What is the area of the entire figure? Oh, yeah, what am I thinking? Yeah, if we know black and brown, we're done, right?
Yeah.
The black, it's 45 plus 36 is 71. So let's write 71 here for this whole area. And this is 80. 80. 80 is this area.
Okay, Joel.
Hold on. Yeah, the thing froze again. Yeah?
Okay.
Think you got it?
I have to rethink. Completely rethink. I did a counting of the variables, and I imagined how some of the variables, how by varying one of the variables, I could set the other variables to get the same data. So let's count variables.
How about if we move this away?
Hold on. This is a new thought.
Right.
So I will use my variables, X, Y, Z, and W.
Guess what? You have a new problem.
Hold on. There are 4 of them. However, the problem gives us only 3 equations. So, unless there's some other information in a general problem where there are 4 variables and 3 equations, if there are any solutions, there will typically be multiple solutions. And so this approach will fail. Typically this approach will fail. There might be some lucky coincidences, and we did not discover any when we analyzed it. So there is an element of the problem that both of us ignored until now. Can you see what that element is, Joel?
Well, right now, I don't know if you see what I'm doing, but I'm moving the page out so we have a clean slate. Do you see how it's a clean slate now?
Okay. Yeah. Now, read the problem again and try to find the one additional piece of information that none of us had mentioned yet.
The length and the width are whole numbers.
Yes, that is
Right.
critical.
I
We realize.
always say this is an approach thing, ready? Because we're into the approach. If you don't know how to do something, look back at the givens. Now, if you go back to the video, I actually said that. If you listen, I said, let's go back to the givens. Guess what? I didn't notice that. But that's what you do in problems when you don't know what to do. You go back to the givens. Thank you, Seth. They're whole numbers.
Okay. And so there are, and so going back, permit me to use my variables.
Yeah, go ahead. Can I put the numbers in though for the areas?
Yeah, sure.
Thank you, Seth. Oh my God. Yes, they're whole numbers. Oh, so you could make guesses.
Yeah.
You
Well,
could make guesses.
let's see how it works out. So again, I'll put X is the length is a common length of rectangle A and rectangle D.
Seth, we know.
Yeah, so I'll put them in again.
You don't have to describe. You have to move on.
Okay, let me be consistent with what we did before. Okay, so what did we do before?
You don't have to be consistent. Just put the variables in.
Okay, 35.
Just do the problem.
Okay, I don't want to be consistent. Okay, what is it?
Oh, come on. Just do the problem.
45 is... Okay. Oh, well,
just make
okay,
up
so
the
I
variables and something important.
And W.
Fine.
4 variables. Now, what are the possibilities? X and Y. X times Y is 35.
Yeah.
So the possibilities are, gosh, do we have to, is it possible?
It's just 5 and 7. Come on.
It could be 1 and 35.
Yeah, but it's not going to be 1 and 35.
How do you know?
Because it's not likely.
How do you know?
It's not likely. It's not likely.
Okay, 35, 30, you have to consider, I'm doing all the positives. 35 is a product of 2 primes.
Right.
And so it's pretty easy to give all the factorizations. There's 5 and 7, 7 and 5, and 1 and 35.
Right.
Okay, now put in what let's do Z. Okay. Z, let's see, what's common? Y and Z. Well, Z times Y equals 45.
Right.
So is there any way to pick a Z so that Z times 35 is 45, where Z is an integer?
Yeah, it's obvious.
No.
It's fine.
So that's rules out.
No. Why? It's this one.
Why? Yeah.
Why
So let me do so here. I'm applying that. Y times Z has to equal 45.
Right.
So 7 does not divide 45. So this gets ruled out. 5 divides 45. And 5 divides 45 by 9. Right? So and 35 does not divide 45, so this is ruled out.
I know. I just said
so the only row that's feasible is this.
This is 7. We're done, Seth. We're done. Just move on. You're not going to be one's going to be sitting there doing all this analysis. You're just going to immediately notice that once you see the trick, you're done.
X and Y, X is 7, Y is 5. Z is 9. But what's W?
Wait, 9. Right, yeah, 9. Well, it's obvious. This is 4.
Okay, 9. Yeah, that's 4. Okay, so great. So the area is 5 plus 4. 5 plus 4, which is 9.
9
times let's see, x and z,
Six.
times 7 plus 9.
Which is 16.
7 plus 9 equals 16. So the area, the answer is 9 times 16.
Right. Yeah, whatever that
Correct.
is. Yeah, whatever that is. Wow.
Yeah.
Yeah. Wow. So what is the major lesson here? When you're stuck in a problem, read the givens. 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 Read the givens.
Yeah. Yeah.
Once you see that true, then the problem just falls right out.
Yeah.
And obviously,
yeah. So an approach. So let's talk about approach to SAT problems.
Yeah.
When the problem mentions whole numbers, when the problem states that unknowns are whole numbers, it becomes a number theory problem as opposed to an algebra problem.
Yeah.
And so what the two of us were, the pitfall we fell into was ignored. We looked at it as an algebra problem and ignored the statement that the lengths and widths are whole numbers.
Right.
What we should have done was responded more quickly to the statement that the lengths and widths were whole numbers.
Right.
And also respond to the givens that the whole numbers of the areas are conveniently factorable.
Right.
In fact, 35 is the product.
Yeah, we know, Seth. We know. It's okay.
Okay, so what we should have done was factor the given areas first.
No. What we should have done, and I'm guilty of this, is if you go back to the video, you can see pretty soon after we got stuck, I said, let's go back to the givens. And I didn't read it carefully enough. And it took a while for Seth to say, let's go back to the givens. Really, the key here is when you get stuck in a problem, go back to the givens and really, really read it carefully. Now, if you don't know what to do, if they're whole numbers, that's a whole other question. When whole numbers, it becomes a factoring number theory question, right?
Yeah. So I think indeed my thinking about the geometry, which we could translate into algebra. I imagined varying. Let's say I suppose we have a solution.
You don't have to say you did wrong.
Yeah, no. My thinking that led me to reread the problem more carefully was that I imagined, suppose X, Y, Z, and W were a solution.
Right.
If I vary Z, can I vary X, Y, and W to obtain a different solution?
Seth,
I can imagine. I have imagined that you can, which led me to think this problem requires more information than the algebraic information, which led me to read it again and see, hey, they're restricting the lengths and widths to whole numbers.
You must say that the analysis you just did is at the level of someone who's already has a PhD. Nobody's going to think the way you just did. But it is possible, though, to think the other way. Didn't you say that there are too many unknowns and not enough equations?
Yes.
Okay, fine. So that's the way I can do it because I'm not a PhD in math. You can, if you do that, you would see, oh my God, 4 unknowns, 3 equations, big trouble. You can't do the problem unless there's something funny going on. And there actually is something funny going on. You're restricting this to whole numbers. So it's really, really helpful in a problem. Oh my God, I do that all the time. Ask yourself, compare how many unknowns to how many equations you have. really got to have the same. Okay, two unknowns, one unknown, one equation. Two unknowns, two equations. Three unknowns, three equations. You got four unknowns, three equations. There's something else going on, and that's what led Seth immediately to realize there is something else going on. We forgot to look at the givens.
Yeah, so that's a pretty good problem.
Yeah,
Pretty interesting.
Yeah. This would you would. I don't think you would see this on a modern test.
No.
But you can see, if you like problems like this, we can do something interesting. We could look at something called area puzzles, and let's check that out. By everyone's going to see all the stuff I have on my browser, but area puzzles. Look, if people like this stuff. Area puzzles. Look at this stuff. Area puzzles. Oh my God! Look at this. Area puzzles. See, you can do things like this. If you like puzzles like this, go ahead. Go on the internet, type area puzzles. You can practice on things like this. We're not going to do these, but I'm just saying that there are these things called area puzzles, and I guess this is one. Okay, so. Obviously, this was an area puzzle. You could go on the internet and find more area puzzles.
Okay. All right. Well, I wonder, could you tell if these area puzzles are algebra problems or number theory problems?
I don't know. We're not. I don't think. I don't know. I don't know. I don't know if we really have the time.
Do they tell you that the lengths of the widths are integer?
I have no. There are probably so many different types of area puzzles. I mean, Here, area puzzles. Look, area puzzles. Okay, yeah, you see all these area puzzles? People want area puzzles. They get area puzzles.
Yeah,
but they are fun. I think they're very, very, very. Oh, look at this, addictive puzzles. Wow. Oh, you can even buy books on these things. So, yeah. So, area puzzles. They're out there. So, So anyway. People can, do them. And maybe some of them are the ones. Now, notice that none of these have restrictions on. Well, we would need to know, right? To know so we don't get burned again as to whether these have to be whole numbers or not. But these look like whole numbers, don't they?
No, you just look. Yeah, please click on it and read it.
I can't really click on it. I don't know. Here.
Yeah. So area, there it is. Is there a statement?
Yeah, they want to know what that area is.
Yeah. They don't tell you anything about integer.
But it's pretty clear that you would think it's an integer. I don't think...
No, I wouldn't think anything.
I don't
know. Don't think, could you solve that? I don't see.
Well, wait, but can I annotate? How do you annotate in this thing? Wait. What do I do? I go like this. I annotate, right? Annotate. Oh, yeah, annotate. So isn't this? Wait, come on. Isn't this a 9?
Yeah.
Come on. Isn't this? How come it's not annotating? I don't know. It's not working.
Yeah, what I would do is, can you annotate?
No, I can't for some reason. But anyway, this height. The height of the 36 thing is a 9, right? Which makes the height of the 25 thing. Yeah, because 3 times something makes 36.
Oh, yeah. Cool.
So the height of that is a 9, which makes the height
of the height of the 36 thing is 9.
Yeah.
So the height of the 25 thing is 5.
5, right, yeah.
Therefore, the width of the 25 thing is 5. Therefore, the width of the question mark thing is 5 plus 3,
which is 8,
also known as 8.
8 times 3,
and the area is therefore 8 times 3, 24 square centimeters.
Okay, so this is so much easier than. This is like a gate. This is so much.
Yeah.
So much
easier. It is an algebra problem because no account was taken. No, the quantities being integers made no constraint
Right.
or role of the problem.
So yeah, this is right. Anyway, you could find area puzzles on the internet and practice with them if you want.
Yeah.
Okay, everyone. So have a great day. This concludes Throwback Thursday. That was an interesting question. And again, go back if you can't, particularly in geometry. If you don't know, if you're getting stuck, look back at the givens. You're probably missing something.
Yeah.
Okay, everyone. Big lesson for today. Hopefully that'll help you. Okay, have a great day.
Well, let me just make a remark about our experience with SAT questions.
Sure.
Sometimes there's information that is unnecessary. Yeah. Typically, the unnecessary information is information about the context in which the problem occurs. Some information about the real world.
Yeah.
I think it is rare in SAT questions for there to be mathematical information that's unnecessary.
Right. And that's usually true of chapter tests in school. It's rare for extra information to be given on regular school tests also. But it does happen.
Yeah.
It does happen.
So an approach, one the thing you might consider in your list of approach strategies is to say, number one, learn go beyond information about the real world, and number two, don't skip over mathematical information.
They're easier said than done. When you're trying to race through these problems, it's easy. We're big talkers. I mean, we did it. We screwed that up. We're big talkers. Yeah, that's right. You could talk all you want, but in practice, when you're running the race,
yeah,
it's a different world.
Yeah. So I think an approach. I think an approach strategy that's a lesson taught from this problem is that SAT problems, if they tell you that quantities are integer, that should pop to a high priority piece of information.
Right. Yeah, that's a good idea. So keep that sort of like programmed back here. Yeah, like a warning flag. Yeah.
So if they talk about integers, if they say whole numbers, or then bring out in your mind the idea of factoring.
Right, or limited only to whole number multiplication.
Yeah,
which severely limits the numbers.
Especially when multiplication is involved,
right?
As it is in this problem, because area is obtained by multiplying the length and the width of rectangles.
Okay, so that concludes today. Sorry it went so long, but hey, we crashed. Like everyone will do. Okay, so we'll see you. More to be learned when you make mistakes in math. More to be learned on those days. Okay, have a great day then. Bye-bye. And then like us, dislike us, give us comments. Please email your SAT math questions to satmathquestionoftheday@gmail.com. Have a great day, everyone. Bye.